Hello and welcome to the basics of trigonometry. Now trigonometry starts out that we are measuring triangles, trig. So we have trigonometry, measure of triangles, and we have these angles in here, and particularly we're going to deal with right triangles. So we have a certain angle here, say theta here, and this guy is in the opposite leg, and this is the adjacent leg, and the big guy across from the 90 is always the hypotenuse. So we have sines, cosines, and tangents. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. It's the ratio of the sides given a very specific angle in the triangle. So we know from the Pythagorean theorem some cool things that if we have like a 3 and a 4, we can find this particular length with the 3 squared plus 4 squared equals that c squared. And we get 9 plus 16, 25 is c squared. And we get, yep, c equals 5. Good. So we get this very definite thing. Or we could alternatively set a very specific angle and find the other angles. But there are a few special triangles where we know the angle measure and the lengths all at once. So let's delve into how we get those. The first one is if we have a triangle that has exactly 60 degrees here, right angle there, that means this up here must be 30. And the way we're able to know exactly what's going on, let's give one side. Let's say this guy over here is 2. Well, how do we know exactly what everything else is with only that information? And here it is. If you flip that guy over, this is also a 30 and that's a 60, and we have a 60, 60, 60 triangle, which means this side's 2 and this side is 2, which means this little guy is a 1. So if we call this b for just a moment, 1 squared plus b squared equals 2 squared. B squared then equals 4 minus 1 is 3, so b is the square root of 3. Oh, good deal right there. So if we take this guy out, a 30, 60, 90 triangle has the ratio. Let's draw that a little straighter then. Okay, close enough. And so if this is a 60, this is a 1 and a 2 and a square root of 3. So anytime you have a 30, 60, 90 triangle, it's going to be either this triangle blown up larger or smaller. For example, let's try this one. Oh, that's a little crooked, but if this is a 60 and this is, say, a 10, then this triangle is exactly 5 times bigger than that one, and you have 5 there, and 5 times the square root of 3 will be up here. And it maintains this same ratio. Let's see if we can shrink it down to where it's a 1. So we divide by 2, that's 1/2, and divide by 2, and that's square root of 3 over 2. It's just proportionate because it's the same shape. So this gives us a fundamental understanding of, like, if you wanted to do the sine of 60 degrees, sine of 60 would be opposite over hypotenuse. The hypotenuse is 1, so this is the sine of 60. This is the cosine of 60, and you can plug those into your calculators and you'll find that. The other very special one is a 45-90, 45-45-90 triangle. So if we were to take this guy, a solid square, side length 1 everywhere, and chop this in half, we know that we just made a 45-45-90 triangle. If we put this little c here and do the 1 squared plus 1 squared equals a c squared, we got 2 equals c squared, and so c would then be the square root of 2. This tells us no matter what 45-45-90 triangle we have, so there's a 45, and if this is 7, well, it's an isosceles triangle, so that's 7, and this is going to be 7 times the square root of 2. It's just this triangle multiplied by the constant ratio 7. Let's do another one where we have, close enough, there's a 45, and that's a right angle. Let's say this is 1. Well, we would have to divide by the square root of 2. 1 over the square root of 2, 1 over the square root of 2. That doesn't look simplified. Let's get the square root off the bottom, times top and bottom by square root of 2. And we actually have square root of 2 over square root of 2 times square root of 2 is 2. So square root of 2 over 2. Now, the reason this is so good, a 45-45-90 triangle, the sine of 45 is this over 1. Which is just that number. The cosine is that one. Look at that, we got it, sine, cosine. So we know exact side lengths and angle measures on these special triangles. And it becomes really kind of cool because now we can introduce what's called the unit circle and find, oh, some pretty doggone cool things for everything. So right here, if you were to label these points going around this is a circle radius 1, and go around and actually label what these points are, see if we'd be able to do this. At 30, you'll notice that it comes right up here, and this is now a 30, 60, 90 triangle. It says the radius is 1, and notice that's just that 30, 60, 90 triangle that we had, and this guy was half as big, and this guy was square root of 3 over 2. So right here we have square root of 3 over 2 is the x, and 1/2 is the y. Now if you were to do the sine of 30 degrees, opposite over hypotenuse is this number because the hypotenuse is 1. So this becomes the sine of 30 degrees. And that guy right there that's the cosine of 30 degrees. So now if we did, say, another one, let's do this one up here, 45. Yeah, there you go. Look at that. Again, radius 1. Well, in the 45, 45, 90 triangle, it was square root of 2 over 2 was the height here. So this point is the square root of 2 over 2 and square root of 2 over 2. And again, that's the sine of 45, and there's the cosine of 45 is the x value. That's pretty cool. Let's do one more so we can make sure we got this. So if we go up here at 60 degrees, head towards that point and come straight down, we now have a 30, 60, 90 triangle where the 30's up here. So the hypotenuse is 1. Oh look, square root of 3 over 2 and 1/2 for that length. And this is now 1/2 out on the x value and square root of 3 over 2 on the y. Here's the sine of 60 degrees is the y value, and the cosine is 1/2. So when you have these points going around, the y value is the sine of the angle of theta, and the x value is the cosine. That is fascinating because we can actually take this right here and now extrapolate and get sine and cosine values for things that are outside of right triangles bigger than 90. So up here, this point is the point 0, 1. If we were to do that and say this is the cosine and that's the sine, cosine of 90 is 0 and sine of 90 is 1. This guy now, the cosine it's the same as that guy right there, but now we're at negative 1/2 because we're in the second quadrant over here, and square root of 3 over 2. And it's fascinating. Let's look at this on a calculator. Make sure we're in degrees, and if we punch in cosine of 120, cosine of 120 degrees, that gives us negative 1/2. That's exactly right. And so this extrapolates to cosine and sine of any angle we want. And let's do sine just to make sure we're good with that. Sine of 120, and it should be square root of 3 over 2. Ooh, I don't know if that's exactly right on. Let's try it. Square root of 3 divided by 2. And indeed, that's exactly what it is. So all of them. And so we can find these values based on this 30, 60, 90, and 45, 45, 90 triangle. So let's try a couple of these so you can see how it works and make sure you're good with that. So the sine of 120, 120 is right up here. We're at a 30, 60, 90 triangle, and the sine would be the y value, so square root of 3 over 2. Tangent of 180, so if we're right down here, tangent, that's important to know, was opposite over adjacent, which was y over x. So tangent is going to be the y value over the x value. So in this case, we have this point is negative 1, 0. So the tangent would be 0 over negative 1, so is 0. The sine of 315, if we come down here to this guy, we're in a 45, 45, 90 triangle. And the sine, let me see, this is square root of 2 over 2, square root of 2 over 2, 1. The sine is the y value. We're down here in the fourth quadrant where y is negative, so it's negative square root of 2 over 2. Let's check that guy on the calculator just to make sure we're doing this thing right. The sine of 315 degrees, and that is negative, oh, I hope it's square root of 2 over 2. Let's punch that in and see if it works. Square root of 2 divided by 2. There you go. So this is how we find the sine, cosine, and tangent of all of these at any time, is by mastering the unit circle. And you really only have four numbers to work with. These guys right here, 1/2 square root of 3 over 2. You have 0 and 1. Oh, and square root of 2 over 2. So 1, 2, 3, 4, 5 different numbers to worry about, and you'll just be flipping them over and upside down to see where you are. This guy will have a sine value of negative square root of 3 over 2 and a cosine value of negative 1/2. Ooh, these guys have the same cosine value. So that is the introduction to the unit circle. Way back, thousands of years, they divided up a circle, this is where we get the idea of degrees, into 360 equal portions. It was roughly the same number of days in a year to come to a complete circle, and so splitting up a circle into these little itty bitty pieces, and 360 of them made a whole circle. That's where we got degrees from. Now we've done other ways, if you do this is 90 degrees here, and it's a quarter of the circle. Other people use circles like in pie charts, and they say, ooh, in a pie chart, let's measure pieces of a circle in percents. So for example, a quarter of a circle would be a 25%, where going all the way around would be 100%. That's one way to do it. There's another way that becomes very convenient in math, and we don't have the reason right for you just now, but it's going to be something that's very handy. And it's called, they divide the circle up into a way such that if the radius, you go the radius on the outer side of the circle right here, that's 1 radian. And it's kind of interesting to watch. I'm going to show you what happens. If you were to go at the radius here and the radius here and go a straight line, radius here, and you picture how many of those you'd be able to make around the circle, this is a 60, 60, 60 triangle, and so you'd be able to make exactly 6 of them. 3 of them would get you halfway around here. If instead of that, you had to suck this guy up, so you went the radius along the circle and along the circle and along the circle, 3 of them wouldn't quite get you straight. So you'd be about like right there. Yeah. So that would be 1, 1, 1, and you'd have 3 in just a little bit. As luck would have it, it's just bigger than 3 with a circle. It takes pi radii around the circle to go half the circle. That may seem like, whoa, how did they get that? Well, it's actually not too bad. You guys know this formula. Circumference is 2 pi r. Now, if the circumference is 2 pi of these radius around the circle, well then, by golly, pi would be halfway around the circle. So pi, these guys are called radians, equals 180 degrees. And you will transfer back and forth between these two. On the calculator, you'll notice I said we needed to make sure we were in degrees. Well, if we switch to mode, the most common one for use from here on out for the rest of trig is going to be radians, and being able to switch back and forth between them is going to be very important. For example, we did a unit circle example where tangent of 180 degrees was 0. Now you're going to take the tangent of some kind of radians, and these will often come in pi's. Enter. Well, it's 0. That's what tangent of 180 was. So here's how it works. If you have 180 degrees, let's do this. Let's match up a few of them. Degrees here and radians here, that's pi. So that means 90 must be this divided by 2. That's right. Some of the ones we already know. 60 degrees. Well, that's 180 divided by 3, so pi over 3. 45 is this guy cut in half. That's pi over 4. So these are in radians, and what was the other one we had? 30. That's pi over 6. So you'll see a lot of this. Like sine of 30 degrees on that unit circle we had was 1/2. So in radians, we would write sine of pi over 6. And let's make sure that comes out to 1/2. Sine of, use that pi button, over 6. Enter. Trigonometry is like a whole new language, and this is a whole new vocabulary. And all I can say is you're going to get used to it as you use these more and more and more. But yeah, so a 30, 60, 90 triangle that we used in the past is now a pi over 3 radian, pi over 6, that's a 30 degree and a 60 degree, and a pi over 2. And the 45, 45, 90 triangle is now a pi over 4 and a pi over 4 and pi over 2. So the unit circle that we just did now looks a little bit different. So here, now we have the points of the unit circle with radian measures, and we're going to try to do that. So this guy would now be pi over 6, pi over 3, pi over 4, pi over 3, and that's pi over 2. So this guy, you'll notice, is now 2/60. This 120 degrees is now 2/60, so we would call that 2 pi over 3. And yeah, so if we wanted the sine of that, we're up square root of 3 over 2, and the cosine is backwards, not backwards, but yes, negative 1/2. So the cosine is negative 1/2, square root of 3 over 2 would be the sine. So let's do a few of these and make sure you can do this. The cosine of 4 pi over 3. So if pi over 3 is 60, so we'd have to go 1, 2, 3 pi over 3 is 1, and then another pi over 3. So this is 4 pi over 3 down here. Good. And the cosine, if we drew this triangle in, the cosine is negative 1/2. The cosine of pi over 6. So pi over 6 is right up here at 30 degrees. Cosine is square root of 3 over 2. The tangent of negative pi over 6. So negative pi over 6 would have to go back this way. So we're right down here. So notice that we're at the tangent of this. So this is negative 1/2, and this is square root of 3 over 2. Tangent is opposite over adjacent. So it's negative 1/2 over square root of 3 over 2. So the 2's will divide off, so we get negative 1 over the square root of 3, and times by the square root of 3, times by the square root of 3, and we get negative square root of 3 over 3. Cosine of pi over 2, so pi over 2 is right here. Cosine of that is the x value, so it's 0. Sine of 2 pi over 3, so we already saw where 2 pi over 3 is. Sine is the y value, square root of 3 over 2. Sine of pi over 4. So yeah, right up there, it's a 45, 45, 92 triangle, square root of 2 over 2. Cosine of negative 7 pi over 6. 6 pi over 6 is right there, so negative pi over 6 is right there. So the cosine of that, you'll notice we've got a 30, 60, 90 triangle, or a pi over 6, pi over 3 triangle. And the cosine is this long leg, square root of 3 over 2, but it's in the negative direction, so negative square root of 3 over 2. All right, so the unit circle is something that you need to master and be able to do on a regular basis because it gives the values of sine, cosine, and tangent for all of them.